Session of the Lakes, Rivers, and Watershed Science Room. Just a few quick reminders to please silence your cell phones. And we also encourage you to just be present and avoid taking pictures of the slide. It can be distracting to the presenters. A reminder that all of these presentations are going to be available on the Extension Lakes website a few weeks after the event. And an email will be sent out to you to let you know when those are available. So now I'm going to quick introduce our speakers who are here to tell us about what the little fish in the shallows can say about our lakes. So first we have Dave Marshall, who received a bachelor's degree at University of Milwaukee in 1975, where he worked at the Center for Great Lakes Research Fisheries Department. He then worked in the DNR's Lakes program from 1976 to 2006. Since retirement in 2006, Dave established the Underwater Habitat Investigations LLC that focuses on lakes management and conservation of native fishes. We also have Lianna Spencer, who received her master's degree after studying environmental conservation at UW-Madison Nelson Institute in 2019. And since then, Lianna has worked as the lake manager for the Lake Ripley Management District. Welcome, Dave and Lianna.
This, can you hear me? Okay. This is an old 35 millimeter slide of a mixed school of blunt-nosed minnows and mimic shiners that I took decades ago from Devil's Lake State Park. And the lower right is a macro close-up of a blunt-nosed minnow. Is this better? Okay, thanks. So many of you have walked along lake shorelines from time to time have probably seen large schools of tiny, shiny fish swim about. Well, it's interesting that that as these fish are important components of lake food chains, they're rarely considered in lake management or monitoring. I was fortunate to grow up on two lakes in Michigan in the 50s and 60s. This lake is about 50 miles south of the Mackinac Bridge in Otsego County, where my grandparents lived in a primitive cabin. And not far away, I had an aunt and uncle that owned a small resort. And in Southwest Michigan, my parents had a small cottage on a clear calcareous lake. The abundance of amphibians, reptiles, dragonflies, and the tiny fish that I would see snorkeling were part of my memories and an important part of my experience. So not long ago, I was kind of interesting to learn, what is the assemblage, the nearshore fish assemblage in these lakes, and there was no information that could be found. And had I asked the same question about two lakes in Wisconsin, I'd probably get the same result. So if you look at a typical deep water glacial lake, most of the biodiversity and fish spawning, nursery habitat, and the basic occurs in that very nearshore area. And in deep water lakes, it's often less than 10% of the whole lake. Yet this is where most changes occur in lakes, mostly due to shoreline development. And the small fishes that form this food chain can act as sentinels and tell us maybe what's going on lake-wide. This is an example of a nearshore fish assemblage, just to give you some of the examples of the fish that occur in the nearshore. In the upper left are darters in the perch family, small, colorful fish that lack swim bladders, so they spend their existence on the bottom. This is the state special concern least darter, which is pretty rare. In the lower left, in the sucker family, is the lake chub sucker. In the middle, upper middle, is the top minnow family, Fundylidae. And this is the state endangered starhead top minnow. In the upper right, the minnow of the largest family, the small shiny fish I mentioned. This is a pug-nosed shiner, which is the state threatened species. And lower right in the catfish family are tadpole madtoms you'll find in some of the shallows and a lot of our lakes. And in the middle, and these aren't to scale, these are much larger, living fossils from 100 to 250 million years ago, long-nosed gar and bowfin. Also are found in a lot of nearshore areas, and they've declined in a lot of lakes. And unfortunately, there's a century-old classification that they are considered rough fish, and a lot of people disdain them because of that classification, even though they're important members of lake food chains. In well, I mentioned that there's a lack of information on nearshore fishes, and there's very, very rarely are these populations surveyed. An exception of that was in the 1970s as part of the fish distribution study. Probably the southern half of Wisconsin's lakes were sampled in the 1970s as part of that survey. It never reached the northern part of the state because the funding was cut in the mid 80s. In 2004, when I was still at the department, we decided to take a second look at some of the lakes in the southeast. We looked at 13 calcareous lakes, and these are all lakes where the water quality did not change over time. The only thing that really changed significantly was the shoreline habitat and the amount of development. And what we found was pretty significant decline in native species. And in this graph here shows the dark bar is the 1970s data, and the orange bar is 2004. So we found declines in most lakes of environmentally sensitive small fishes. And then we didn't just survey the fish, we also looked at the habitat. So we did pier counts in all the lakes we surveyed. And we found a pretty significant correlation as the numbers of piers, the pier density increased, the numbers of these environmentally sensitive fish declined. That's a pretty significant R-squared value. So that, correlation doesn't necessarily mean causation, but also in 2004, we did a direct peer impact study on Lake Ripley and Rock Lake in Jefferson County. And we found that the habitat was significantly altered beneath piers due to shading. And we also found lower numbers of fish, macroinvertebrates, and the habitat itself, aquatic plants. Radomski most accurately described what is going on. So the fish declines that we observed do not only reflect direct impacts of piers, but associated activities that do occur around piers. And piers typically indicate developed shorelines. So we presented that information in 2005 Lakes Convention. So what has happened more recently? Wisconsin does not have a systematic program to sample nearshore fish, but some of us old retired DNR geezers do it from time to time at the request of different lake organizations and local governments. We typically use towed DC electroshocking gear and or small mesh seines, as these students in Geneva Lake are demonstrating. So I'm going to give you some examples. We had some pretty interesting findings in some of these lakes we sampled. From 2017 through 2020, we sampled the 4 Yahara chain of lakes in Dane County. There had already been a documentation that species had become extirpated in these lakes, but we wanted to do an update. And so what we found was, and that we didn't expect this, but we found fewer non-game fish along riprap shorelines than non-riprap shorelines. And the most interesting thing is that Lake Higanza is the most eutrophic, has the worst water quality of the 4 lakes, but it has a lot less riprap. And we actually found higher numbers and species richness of non-game species in Lake Higanza. So this graph shows a comparison of habitat types. Research has demonstrated that in lakes where habitat becomes altered, fish in the sunfish family tend to increase. And what we found, we didn't see a lot of difference between non-riprapped and riprap shorelines as far as the percent frequency of occurrence between species such as bluegills and bass, and also yellow bullheads, which are fairly tolerant. But looking at some of the small non-game species and also long-nosed gar, we would only find those or find most of them in areas where there is they weren't riprapped. And this slide kind of gives a diagram of what actually happens when shorelines become riprapped. They immediately become deeper, and what is lost is this shallow water interface. And this is an escape area for a lot of the small fishes that form these food chains. And so during growing season, a lot of these small darters and minnows will spend their entire growing season in these shallow areas, but they've disappeared along riprap shores, and in a lot of lakes that have become mostly riprap, you don't find these habitats anymore. Rock Lake in Jefferson County is another lake we looked at. In addition to finding some of the rare species, such as the state special concern least darter, the declining western banded killifish, the threatened pug-nosed shiner, and some other species, we found a really surprising fish, the state endangered slender madtom. This species had only been known to live in cool, fast, clear water streams. And yet we found it living in this lake. This is the only place in the world where it's ever been found in a lake. And yet we found it along shorelines where there's, they weren't riprapped. We didn't find any in riprapped shorelines, but where there's these shallow shoals of cobble and gravel. Another lake we looked at more recently is Nagawicca Lake in Waukesha County. We didn't actually do a big survey in this, but we were asked to look at potential impacts of a proposed large shopping pier to be built within a critical habitat area. And this lake is known to have some rare species, but there hasn't been surveys done in many decades. I surveyed just the footprint of the proposed pier and found western banded killifish, which I mentioned has been declining across its range. It hadn't been previously documented in that lake. So without survey data, it's hard to make decisions, whether or not projects like this should move forward. Also, I previously mentioned the slender madtom, which is very rare, and we actually found it in Rock Lake. Probably one of the most important habitats for the slender madtom is the Bark River in Waukesha County. And the Nagawicca Lake is part of the Bark River chain. So we don't know whether or not that the slender madtom may also exist in Nagawicca Lake. So some years ago, I looked at some issues in Pleasant Lake in Washira County. There was concern over high capacity wells that may be lowering the lake levels and affecting the ecology of the lake. Of particular concern was this wetland along the western side of the lake. So we did a nearshore survey along this wetland and found that it was very critical habitat for some non-game species, particularly the western banded killifish. And also located there was a small tributary with water depth of maybe an inch that connected to a small pond where the fish spawned and actually was kind of a nursery habitat for this species. So what would happen if the lake dropped a few inches and they could no longer reach that critical habitat for spawning and nursery habitat? Just down gradient, very close to Pleasant Lake, is a spring pond known as Chaffee Springs. It actually forms the headwaters of the McCann River. And no one had really looked at the spring pond before, so we did a non-game fish survey there, and we found the first documented state special concern least starter that lived in that spring pond that may be affected by declining groundwater discharge. But the most significant thing we found was that the spring pond and the surrounding habitat was a calcareous fen. This had never been known before. So it's kind of a demonstration that these types of surveys can yield other information beyond just the fish themselves, and that can be useful for management purposes. So last 3 years or so, we've done some surveys on Geneva Lake for the Geneva Lake Environmental Agency. And there are some rare species in that lake still, the least starter, the western banded killifish, for instance. The interesting thing we found in this lake is that areas, shorelines where there was really good habitat, we still weren't finding any fish. And the only habitat observation that could potentially explain this is that these shorelines were just being pounded by waves. There's a lot of research that demonstrated that that boat wakes are actually far more stressful than wind-driven waves that are where the turbulence is more regular. But the turbulence from boat wakes can be chaotic. And so we recommended as a potential management option is to create a barrier reef, an offshore reef to maybe create some protected area and then monitor the results. And so that was one management recommendation that came out of that lake survey. So far, I've just talked about surveys of glacial lakes. We've also looked at oxbow lakes, which are cutoff channels from rivers. And we've done a lot of surveys in the southern part of the state, in particular the lower Wisconsin State Riverway. And lower Wisconsin Riverway has had, when we started these surveys, it had 3 sites where the state endangered starhead top minnow had been identified. The late George Becker had said that this species was so rare that a top minnow sanctuary should have been created for it. But by the time we were done with surveying after a couple of years, we found it was fairly abundant, and we found it at numerous places up and down the river. We had actually thought that George Becker's vision of a top minnow sanctuary was the lower Wisconsin State Riverway. But our continuing monitoring, unfortunately, yielded some other bad news. Water quality changed significantly by about 2011. This is one of the sloughs, Norton Slough, in 2008, just ideal for a lot of for biodiversity and a lot of non-game species. And then by 2011, it became, this and other oxbows became smothered by blankets of free-floating plants, which are actually duckweeds and filamentous algae. And so what the free-floating plants do, they eliminate the habitat for a top minnow like starhead top minnows. And then for the fish underneath, well, they can't live because there's no oxygen. These become anoxic as the interface with the atmosphere is cut off and there's no photosynthesis underneath. So we looked at this more closely and we did a study, and we found that it was due to groundwater contaminated with nitrates. Most of the oxbows along the riverway are spring fed with a driftless area oxbow that became contaminated with nitrates as agriculture changed in the 21st century to become more industrialized, and with excessive applications of fertilizers over the sand terrace, which then become easily leached into the groundwater. So we had nitrate concentrations based on our well monitoring of up to 40 parts per million discharging. And so this was the first ever case in Wisconsin where nitrate was the driving factor for eutrophication in groundwater as opposed to phosphorus. So we actually published this in the Lake and Reservoir Management. So this is a case, well, we had this, what we thought was the George Becker's top minnow sanctuary. We decided to take some action. And this is a farm my wife and I own in Iowa County. We had in the mid 90s, we constructed a small wildlife pond. So we decided to use this as the first non-game conservation aquaculture project in the state. It's only a quarter of an acre. So we went to the river and we got the permits. I had an endangered species permit, a fish farm license, and then I ended up getting stocking permits and everything, and as well as health inspections for the fish. So, but we gathered about 120, 130 fish, starheads, and introduced them into this pond. And this shows us harvesting, like a lot of these studies. I didn't mention all the citations, but we published a lot of the information we've done with these surveys. So here we're harvesting to stock. And so the idea was to raise the fish, collect them, and stock them out of harm's way. So starhead top minnows in the Wisconsin River system were not found below the dam. So we decided to move them out of harm's way and move them above the Prairie du Sac Dam in Sauk City. And so out of the, roughly 130 that we had we stocked, or that we raised, we were able to generate over 7,000 that we actually stocked. And we stocked above the dam in some backwaters of Lake Wisconsin. And this is a backwater they've done really well. Another one, and then some sloughs up here. And since then, and again, another paper that we've published on this, we've expanded this to the lake chubsucker. The lake chubsucker is a state special concern species, but its distribution in the Wisconsin River is also below the dam. And so now we've successfully raised those along with the starhead top minnows, and we've been stocking those at this particular site. They're not as prolific at producing. And so our surveys, as we've done our surveys to look at the status, and we found that we successfully established populations at these sites. We also found the first ever sighting of a western banded killifish in the Wisconsin River system. So we keep finding all these surprises in all these surveys. So these are just some of the examples where lakes program should maybe consider looking at non-game fish. I'm 74, I'm getting too old to do it, so hopefully some of you will pick that up. So now I'm going to introduce
Here, you want the water, you think?
okay.
All right, give me 1 sec. I got your badge, Dave, just so you know. I'll get there. Perfect. Good morning. Can you all hear me okay? Great. Hello, I am Lianna Spencer. I'm the lake manager for the Lake Ripley Management District, and I'm going to be giving you guys a little bit of a case study of what Dave's talked about and what Lake Ripley has been doing for the last 30 years. Awesome. So the Lake Ripley Management District is a special purpose local unit of government representing and acting on behalf of area property owners to protect and manage Lake Ripley in Cambridge, Wisconsin. The district officially formed in 1990 by a resolution of the Jefferson County Board and under Chapter 33 of the Wisconsin State Statutes. The district's mission is to preserve and enhance Lake Ripley's water quality, its fish and wildlife communities, and its overall ecological health while ensuring public access and use of the lake that is safe, fair, and practical. Lake Ripley has been a popular recreational destination since the completion of a railroad line that traveled from Milwaukee to Madison in 1881. The first summer home was built on the lake in 1882, and by 1924, there were hotels, cottages, and semi-permanent homes that were popping up along the shoreline. Lake Ripley continued to get developed over the next 50 years. Agricultural mechanization greatly increased, and the use of synthetic fertilizers became common practice. This resulted in a larger portion of land within our watershed under cultivation, as well as increased rates of nutrient application onto the landscape, greater soil erosion, and increased nutrient runoff. Residential construction also affected the lake by increasing soil erosion rates and by contributing sewage effluent as a result of failing septic systems. By 1986, Lake Ripley had been chosen by the DNR as one of the 50 states in the lake for long-term trends monitoring. Just 3 years later, the growth of the invasive Eurasian water milfoil exploded and blanketed about 40% of the lake with thick mats of vegetation, prompting property owners to organize for the purpose of creating a lake district with specific intention to create a weed harvesting program to help manage the prolific weed growth. Eurasian water milfoil was quickly infiltrating the lake, replacing native vegetation and leading to a loss of quality habitat in the lake. Lake planning and assessment projects generally focus on traditional trophic indicators, such as conducting plant inventory surveys, water quality sampling, and sport fish inventories. However, other ecological indicators, such as nearshore and non-game fish diversity, are often overlooked in lake evaluations. Some non-game nearshore fish species are very intolerant of environmental changes and degradation and have been described as canaries in the coal mine. These fish provide important ecological linkages that may reveal ecosystem stresses before traditional parameters reveal water quality problems. As we all know, fisheries play a central role in maintaining a healthy lake ecosystem through their interactions with other biological communities. They are biotic indicators of environmental quality. Lake Ripley has long been considered one of Wisconsin's finest largemouth bass lakes and is famous for producing the state record in 1940. In addition to largemouth bass, a 1982 fish distribution study found the lake to support as many as 37 fish species, including many small nearshore non-game fishes intolerant of environmental degradation and uncommon at the state level. There is no debating that Lake Ripley has a robust game fish population on the lake. Check it out. For example, the DNR put out pike nets around the lake for sampling, and during the survey, they sampled 12,596 fish from 21 different species. The most abundant species was bluegill at 61%, followed by pumpkin seed at 13% and yellow bullhead at 10%. However, most surveys and studies focus on game fish production, and management can tend to lead towards protecting those game fish. But what about our nearshore non-game fish? They need studying and protecting too. Nearshore non-game fish live in the shallow zones of the lake and are often missed during electrofishing surveys. Declines of these small darters and minnows can reveal problems in our lake before the abundance and growth rates of game fish are impacted. That's just one of the reasons why it's important to conduct these surveys. Little fish can provide us with insight on what's happening inside our lakes. Fortunately, the Lake Ripley Management District and the DNR have done periodic inventories of these fish species, giving us a baseline for our lake. The first shoreline fish seining survey was conducted in 1975 to assess these non-shore, non-game fish species, as well as juvenile game fish. 10 sites around the lake were sampled. The survey showed that 18 native species were found, with 12 of those species being nearshore non-game fish, including the western banded killifish and the least darter, which is pictured here in the bottom left. The next survey was conducted during the summer of 2004. Only 11 native fish species were recorded. Unfortunately, these results did show a precipitous decline of the small, non-game, nearshore fish species, including the pug-nose shiner, western banded killifish, least darter, and others. Overall, 7, can you hear that better? Let me pick that up. Better? Yeah. Overall, 7 native fish species were no longer present in the lake compared to the 1975 data. 6 of those species were the nearshore non-game fish. We conducted the survey again 8 years later in 2012, with the primary objective being to determine the extent of the population changes compared to the previous 2 surveys. This survey was conducted using small mesh seining and a towed DC electroshocker. The combination of sampling gear was chosen to effectively sample the different niches, behaviors, and habitat preferences of the diverse fish populations. Nearshore electrofishing, in particular, allowed for the sampling of fish species that are less likely to be collected using scenes, particularly where habitats included obstacles such as piers, boat lifts, submerged timber, or large rocks. The 10 sites that were evaluated in 1975 and 2004 were targeted, and 4 new sites were added, specifically to represent what we believed to be favorable habitat conditions, such as natural or relatively undisturbed shorelines, abundance of littoral cover, and connections to mapped critical habitat designation areas. The survey results brought more bad news. There were significant declines in total fish species richness, numbers of intolerant species, and number of rare species. However, 4 additional native fish species not previously found as part of the nearshore seining surveys were found this time. They included the yellow bullhead, tadpole mad tom, black striped top minnow, and the fantail darter. Consistent with the 2004 survey, these 2012 results suggested that the least darter, western banded killifish, black chin shiner, pug nose shiner, and black nose shiner had been extirpated from Lake Ripley. Over the 36-year study period, seining results indicated a possible loss of 7 native species and declines in both rare and intolerant species. Although very disappointing for us, the data was consistent with similar trends that were reported throughout southern Wisconsin for decades. The declines in Lake Ripley coincide with habitat degradation, habitat fragmentation, environmental pollution, and the invasion of Eurasian water milfoil. For those of you who aren't familiar with Lake Ripley, here are 2 maps that show the lake. The map on the left shows the 2004 sampling locations, and the map on the right shows the 2012 sampling locations, including the 4 additional locations that were added. The 4 sites added in those locations were proposed as critical habitat designation areas, and I'll talk a little bit more about those in the next presentation. But just to point it out, these in the bays, 14 and then 13 up there, those were the 4 new sites that were added. 8 years later, in 2020, the district conducted our 4th nearshore non-game fish survey. The goal of this survey was to determine the current status of the small non-game fishes of the lake, to document possible changes that had occurred since previous surveys, to assess current nearshore habitat conditions, and to evaluate whether reintroduction of the presumed extirpated species might be warranted. The crew sampled 10 locations around the lake using electroshockers to sample the fish. Unfortunately, since 2012, 4 sites had degraded in habitat and were removed from this survey. The crew chose to use electroshocking for this survey, as all 5 of the presumed extirpated species were associated with either the bottom of the lake or areas of aquatic vegetation. Following a standardized sampling procedure, the crew shocked 200 feet of shoreline wherever possible. A qualitative habitat assessment focusing on bottom substrate, aquatic vegetation, hiding cover for fish, and shoreline and riparian conditions was also conducted. From all 10 sites, the crew collected a total of 14 species, with bluegill and largemouth bass being the most common fish caught. Surprisingly, at Site 3, 2 least starters were collected. This indicated that the species had not been extirpated from the lake as previously assumed, which was super great news for us. As discussed, prior to the 2020 survey, the district assumed that the 5 once common non-game nearshore fish species had disappeared from the lake. As I just shared, the 2020 results indicated that one of those species, the least starter, is still here. You can see it right here. And let me pop over one more. And there it is in Dave's hand. It was really cool. You have to be there, I guess. Presumably, this species has remained present since 1975 and had been missed in the 2004 and 2012 surveys. A recent recolonization since 2012 seemed highly unlikely, and there are no nearby sources of the leaf starter. As it is such a small species that is bottom dwelling and associated with areas of aquatic plant cover, it is not at all surprising that it could have been missed during the previous studies, especially if the population in the lake is small. Finding the leaf starter has made our staff incredibly hopeful that some of these small fish exist, and Lake Ripley still has quality habitat in our lake to be able to support populations of these species. One of the questions we found ourselves asking was, why did these 4 species disappear? The expansion of Eurasian water milfoil crowding out many native plants, rapidly changing the habitat conditions, may have contributed to their disappearance. And even more hopeful, perhaps one possible reason for the rediscovery of the leaf starter is the fact that the district has been managing Eurasian water milfoil for, for over 30 years. And that management has allowed the submerged native vegetation to make a comeback, creating suitable habitat for these non-game fish. In 2020, the district updated our 10-year lake management plan. And within this plan, we added a plan to do nearshore non-game fish surveys every 5 years, along with other repeated surveys that would give us data about the quality of the habitat in and around our lake. In fact, we're due for our next survey this year. A quick caveat, I mentioned critical habitat areas, and I want to touch on what they are. Critical habitat designations are intended to identify areas which, if disturbed, would adversely affect public use and enjoyment of the lake. Such areas include locations important in maintaining fish and wildlife habitat, water quality, water quantity, or reaches of the shore that are predominantly natural in appearance or that screen man-made or artificial features. Since 1995, the district has been working to designate 8 different areas of the lake that we deemed to be critical due to the presence of aquatic vegetation that covers that provides critical or unique fish or wildlife habitat, including seasonal or life stage requirements, or offer water quality or erosion control benefits to the area. All of that to say, the 2020 Nearshore Non-Game Fish Survey helped us designate these 8 different areas because of the fish species present and the habitat present within the lake. It took the district almost 30 years to get these 8 areas protected, but we did it. In 2004, the DNR designated 8 critical habitat designations in Lake Ripley. One of the major takeaways from the 2020 non-game fish survey was that considering the presence of suitable habitat, it would seem as if reintroduction of one or more of the 4 eliminated species may be an effective strategy to improve the small nearshore non-game fish community in Lake Ripley. Reintroductions such as these have been studied and considered a viable management approach. There have even been successful reintroductions in New York, Minnesota, and Illinois. Since we found the leaf starter in the lake, we have tried multiple times to reintroduce Western banded killifish. The lack of infrastructure and lack of monies prevented any of these projects from moving forward, although we are still trying. It is our hopes that when we complete our upcoming non-game fish survey this year, we will find more evidence of a thriving leaf starter population, and even more hopeful, another extirpated species. The west side of Lake Ripley, pictured here, has areas of natural shoreline and riparian areas with extensive native submerged vegetation. Habitat at this site and other naturally vegetated sites around the lake appear suitable for non-game fish species such as the pug-nosed shiner, black chin shiner, and western banded killifish. This summer, Dave and I will be completing the 5th nearshore non-game fish survey on Lake Ripley. We're excited to get on the water and search for these incredibly important yet often overlooked fish. Documenting these fish species allows the district to explore new ideas and projects, such as reintroducing the western banded killifish. As the district continues to improve the way that we protect Lake Ripley, we will keep looking for new or improved ways to protect all of the little things that make this lake special, including its little fish. Thank you.
All right, thank you so much, Dave and Lianna, for that presentation. We have about, I think, 10 minutes left here for questions before the kickoff plenary starts at 9 a.m. So we can start taking questions. There's a gentleman right there in the back, the blue.
This will be our first one. Our ordinance was enacted last year and we're due for our survey this summer. Yes. Yeah. Yeah. Repeat the question. The question was, how do we communicate that the surveys we're doing for the nearshore non-game fish are important and meaningful to the district? And the answer is that we communicate. We have a quarterly newsletter that we send out to all of our residents called the Ripples. And we often add information about those surveys on there. We have a Facebook page that we post things to quite a bit. And we also have a website. If you're interested in any of these survey results, on our website, lakeripley.org, you'll find all those results, surveys, reports associated with these near shore non-game fish surveys, as well as all the other surveys that we do. Yeah.
You give an overview of your legal ordinance?
Let's talk about that after, if you don't mind. Come talk to me about that after. I feel like that could go in all kinds of different directions, but I'm happy to chat with you about it. Yeah, of course.
Historically, how long, so you can have a comparison before and after?
Sure, good question. We had about 5 wake boats that were residential folks operating on the lake every year. One of them we've known we're operating on the lake for about 10 years. And then, you know, we have some transient folks that come in and use their boats when they rent vacation homes or something like that, but about 5. Yeah, thank you. Paul.
Virtual question for both of you, I think. What is your message to riparians who only care about game fish?
I'll let you take that one, Dave.
Game fish have to eat.
Yes. Yeah.
Uh, Can you repeat the question to me? Oh. Yeah, it depends in the situation. I think in the Madison Lakes, for instance, they manage the lake at a higher level. If they could lower the lake level a little bit, which could ultimately reduce some of the flooding problems they've had, the riprap wouldn't cause a problem then, because then you would restore the shallow shoal. And I don't know, you won't have that option in a lot of lakes. Yeah, you'd have to look into it carefully with each situation. And you mentioned you'll see fish under piers. Typically, it's usually sunfish species, and they use piers as kind of a staging area, particularly when other forms of habitat have declined quite a bit. So, sorry I couldn't answer that better, but. Well, this is just a hypothesis. She wanted to know about building rock reefs that I suggested at Geneva Lake, and this was just something that needs further investigation. Something that we recommended because, you know, it's well understood that the turbulence from boat waste can really undermine the nearshore ecology and make it stressful. So it might be something worth trying. And, you know, it probably want to work with an engineering firm to develop standards. And, you know, you'd have to be constructed so that it doesn't impede navigation. There are a lot of issues related to that. But it's just a concept we threw out. You know, doing these types of surveys, you can see some potential problems and you come up with some ideas that you can explore further down the road. This gentleman wanted to know if frogs can be an indicator of environmental change as fishes. And I would say yes. Anytime you start losing components of the ecosystem, and I love frogs too. You know, I liked frogs more than fish when I was a kid, but I ended up looking at fish more. And so I think amphibian surveys are definitely useful. They should be part of this too, not just non-game fishes.
The Lake District we do participate in the Wisconsin Frog and Toad surveys, so don't worry, we're tracking that.
I'm not real familiar with fish stocking programs in lakes, but I know that from what I know, it's always been typically panfish or game fish. So what are the guidelines or suggestions or possibilities of stocking small non-game fish? What is that common, not common?
The question was, what was the possibility of stocking nearshore non-game fish species? What's the process and what do the permits look like? And Dave's done that a lot more than me, so I'll hand this question over to him.
Typically, lake districts will get stocking permits from DNR. You have to get stocking permits before you put any fish in. It has to be approved by DNR. Often what is stocked as far as non-game are fathead minnows in the minnow family, but in the natural ecosystems, they don't live long. So it's kind of a put and take situation. I've suggested to some breeders that they consider blunt-nosed minnows. They're both the same genus, but the blunt-nosed minnows are able to sustain themselves, but it's probably not a good business model if you want to sell a lot of fish. So otherwise, stocking non-game fish in lakes is not very common beyond fathead minnows. And, what we've been doing with the starhead top minnows is fairly unique in the state. We'll definitely protect the habitat, improve the habitat, but as Lianna mentioned, it's worth considering conservation aquaculture to kind of restore these populations. I think it should be part of the whole picture.
Speak to that too. The Lake District is currently trying to have a project that Dave's helping us with to reintroduce Western banded killifish. So the process I went through before my grant didn't get accepted was looking for a spot in the lake where it'd be suitable. So in a slow moving, calm area, and finding an area or a business or a location that had some infrastructure where I could raise these fish. And luckily there was like an abandoned, remember on the State Farm Road, there was an abandoned aquaculture center. So I called the business owner. I was like, would you be interested? He's like, absolutely. We don't use these. So luckily for me, it was pretty easy, but it's just finding the tools to be able to do that in your lake. And if you have a board that supports you or an association that supports you, I don't think it's impossible. So ask me in 5 years. Hopefully we have something.
It'd be great if DNR had some grants to fund this type of stuff.
One more online. I guess there's two. Maybe you have really quick answers to this. One is, how has EWM management evolved over time on Lake Ripley? And the other one was asking about fish sticks and how that can help nearshore species, as in tree drops into the shallows.
Take the first one, you take the second. The district has been managing Eurasian water milfoil for 30 years. We do plant inventory surveys regularly to see where it's moved. So we alter our weed harvesting routes to specifically focus on the plant itself. We've actually seen a 70% decrease since 1974, which is incredible. So that's how we manage it. And feel free to reach out to me if you're online. My email should be in the presentation. So if you want more, I'm happy to answer.
Fish sticks may help if they're really close to shore. So tree drops are beneficial. But the most important thing is avoid armoring and removing of the vegetation.
All right, let's give it up one more time for Dave and Lianna. Thank you so much.